Hey Kryptonites, this is Colin from Crypto Coin Growth. Today we're here with Pedro from Ople, and he's going to explain his AI software to us. And enjoy. Thank you, Pedro. Go ahead.
Hey, thanks. So, regular process of a data scientist doing his project, right? He formulates a problem with the business team, then he has to put a target that he's trying to predict that solves that problem. He puts together a data set around it, right? At that point of the project, he'll start then doing feature engineering, model selection, hyperparameter optimization, tuning, and then productionizing. All those things that I just said, people will spend 1 to 4 months just tuning things over and over and over. And that whole component of their jobs can be automated. And that's what we're doing. You should, when you get to that part of the project, you should just be able to push a button and wait an hour or two and be done with it and move on to the next project to try to bring more value to your company. Right? So what the software is something that learns the same way a data scientist does, which means currently some of the methodologies out there, it's what's called learning to learn. How they work is they try to run a few algorithms and they get the feedback of how they did. And then based on that, they run a few more, and then back and forth, until they get to the best possible algorithm. That is self-contained within one project. And when I look back at my own career as a scientist, I think, okay, I was doing a little bit of that manually, but every time I did the next project, I was better at it, and I was faster at it, which means I learned something that allowed me to do that learning to learn better. Yeah. So I was learning to learn to learn. Sure. And so we taught our machine to learn to learn to learn. And that's one of the differentiators. So with every single project that our software sees, it gets smarter the same way a data scientist will. So, you know, it's learning and growing just the way a scientist would. The difference is this is going to be able to see more projects than any scientist in their whole lifetimes. So there's no comparison, right? Nobody can compete with the amount of volume this thing can see.
Great. Can you go ahead and show us a demo on this?
Yeah, sure. Okay, so I'm selecting a data set. It's uploading it right now. It's running on AWS. So what you're seeing here is just the front end, and the data set is actually on this machine, and it's uploading it to the cloud because that's where all the models are going to be spun up and run. Right? So it should take a minute. The next step that you're going to see is simply validating that the data that was loaded in our system is correct. Right? Simple checks and balances. So there you go. It's done. You can upload a test set separately or not. If you don't, we take care of that, separating it and creating our own test set from the training set that you submitted. Now this is the validation. It's just reading saying, look, we think you gave us this. 2,000 training instances, how many features, how many of them numeric, categorical, the target. You can look to see how many missing values there are, the range of values, just making sure everything is okay. If there's something wrong, you can actually change what kind of feature that is. And if everything is okay, you just have to hit next. It's creating a name for the demo. And then selecting, is it classification, whether it's binary or multi-class, or is it regression, right? Regression would be predicting a price of a stock, predicting an actual value. Classification is this person going to churn or not, right? Should I show this person this ad, yes or no? So you select classification. You don't have to select the criteria we're going to optimize on if you don't want to. So it could be that simple, or you can. So if you care about accuracy, you could say, this is what I'm optimizing on. That's it. You're done. This is the work that most times will take about 4 months.
Oh my God.
This particular demo, this is a small data set. It should be done in about 20 minutes. So what you see here is all the previous jobs that I started earlier in the day. It's going to be starting to run this one, but I can open one that I started earlier with that same data set. So what you see here is all the algorithms that somebody would run in the natural course of the project, right? Gradient boosting machine, random forest, logistic regression, neural networks. And each dot in these graphs is an entire model that was built. And this is how it's trying to optimize that model. What you see below is how those models performed. And those are used as benchmarks. That's not the final model that we're going to supply to the customer. That's just to give them confidence that if you were to run these, right, are they going to beat what we are giving them anyway? Which what we're giving them is something called base behavioral simulation. The idea there is neural networks are great from the advantage point of once it's trained, compared to the big ensembles that win Kaggle competitions, they can predict very quickly, and they have a small memory footprint. So you can deploy these on a phone, on anything. They don't have to run on a big computer. Unfortunately, outside of images, as much as it's the opposite of what the media says, deep learning doesn't do so well. I don't think they've won a single Kaggle competition. It's always big ensembles. So we wanted to get the best of both worlds, and that's why we created BASE. Behavioral simulation is the way of training a neural network to assimilate the behavior of any other kind of model. So we get the speed and the memory footprint of a neural network and the accuracy of the biggest monstrosity that nobody would ever put in production, just to win a competition. Like the famous $1 million Netflix prize, they paid $1 million for it. Yeah. They never used it. It cost $1 million because it was improductionizable. One of the Kaggle competitions that we ended up testing on, we were third or fourth decimal place away from first place. Insignificant difference. The difference is that all the top 50 places in that competition, their models took 14 hours to predict on the data. It took us 34 seconds to predict on the data, right? So it's the difference between, yeah, now I have to rent all of AWS to run my startup versus, no, I can run it on a laptop, right? So that's the importance of BASE.
So where can a business go to find out more about your product and either to register or to talk to a salesperson?
Ople.ai.
Ople.ai.
O-P-L-E.
Okay. Wonderful. Well, hey, thank you very much. And we'll be sure to send people your way.
All right.